We all think we know how hair works, right? I mean, for decades, the story's been the same. New cells pop up at the root, they push the old hair out. Simple. But what if I told you that entire story might be completely wrong?
So yeah, think about that for a second. Because it turns out a brand new study is suggesting the whole thing is driven by a force we just never even saw it coming. Okay, so this is the heart of it right here. The old story we all learned, hair gets pushed out from the root. The new discovery? Nope. Hair is actually being pulled upward by this whole network of moving cells around it. Let's dig into what that actually means. I mean, for decades, this was just settled science. The biology textbooks all said the same thing. The engine for hair growth was way down deep inside the hair follicle, right at the very root. And the idea was so simple. You've got the base of the hair, right? The bulb. New cells are made there. They divide, they multiply. And as they pile up, they just push the older hair shaft up and out of your skin. It's clean, it's logical, a nice, simple push. Makes total sense, right? Well, that simple, elegant idea, it just got completely flipped on its head. See, thanks to some really advanced 3D imaging, scientists could actually watch living, growing human hair follicles in real time. And what they saw? Well, it changes absolutely everything. The lead author, Dr. Inez Sequeira, summed it up perfectly. She said, they found hair isn't just this passive thing getting shoved out. Instead, it's being actively pulled upwards by the tissue around it. Tissue that's acting, and this is her phrase, almost like a tiny motor. So, okay, how in the world do you prove something that sounds so backwards? Well, the researchers came up with this really clever set of experiments to figure out what was really driving hair growth. It was basically a two-part test. For step one, they went after the old push theory. They figured, let's block cell division and see what happens. Then, for step two, they tested the new pull theory by blocking the cell's ability to even move. And the results from that first part were, wow. Just stunning. Think about it. If the push theory was right, stopping new cells should have stopped hair growth dead in its tracks. But it didn't. The hair just kept on growing, almost like nothing had changed. This was a huge crack in that old theory. So then came part two. This time, they went after something else entirely. A protein called actin. It's what cells absolutely need to be able to contract and move around. Now, if this new pull theory was the real deal, messing with actin should have a massive effect. And boy, did it. The result was just dramatic. Hair growth dropped by more than 80%. That was it. That was the smoking gun. It proved it wasn't about making new cells. It was all about the movement of the cells that were already there. Which, of course, brings up the next obvious question, right? If there's this tiny motor pulling the hair out, what in the world is it? And how does it work? Okay, so the main player here is a thing called the outer root sheath. The easiest way to picture it is like a sleeve made of cells that's wrapped tightly around the hair shaft. That sheath, that's the tiny motor they were talking about. And this is where it gets really cool. The scientists watched these cells, and they saw them moving together in this coordinated spiral. But get this, they were moving downward. It's like a corkscrew turning down into a bottle. And that strange downward spiral is what, somehow, creates this incredibly powerful upward pull on the hair. Wild, right? Dr. Sequeira called it a fascinating choreography, and you can totally see why. This isn't just a simple push anymore. It's this intricate, coordinated dance. All these cells working in perfect sync to literally pull a strand of hair up into the world. So look, this is way more than just a neat piece of biology trivia. Understanding how this actually works has some pretty profound implications for medicine, for science, for a lot of things. So why should you care? Well, because it opens up totally new doors. Think about hair loss treatments. Instead of just focusing on the chemistry, we can now look for ways to support the physical, mechanical side of things. It means we can test drugs better. And it goes even bigger than that. It has huge implications for things like tissue engineering. It's teaching us that to build new tissues, it's not just about having the right cells, you need to have the right physical forces at play too. When you boil it all down, what this discovery really shows us is how important the physics of biology, biophysics, really is. It's telling us that all those physical forces, the pulling, the contracting, the sheer movement,
They are every bit as important in shaping our bodies as the chemical signals we spent so much time studying. And that really leaves us with one last big question to chew on. If we got something as basic as every day as how our own hair grows wrong for so long, what other facts in our biology textbooks are just waiting for their own second look? Makes you wonder, doesn't it? Thanks for watching.